Assalamualaikum. So today we will present about audio amplifier class AB. So here our team member.
My name is Siti Nurlidatun binti Zulkifli.
I am Sharifah Nurul Shakira binti Said Aziz.
I am Siti Afrika binti Azmi.
The main purpose of this assignment is to design a Class AB power amplifier which follows the audio preamplifier and drives the speaker. In this application, the maximum signal power to 8 ohm speaker should be approximately 6 watt for a frequency range to 70 Hz to 5 kHz. Usually, the audio power amplifier is a kind of electronic amplifier that amplifies low power audio signal, which is the low power signal are always between 20 Hz to 20 kHz to a level that can be suitable for driving the loudspeaker. Nowadays, all types of electronic that could be make sounds are widely using the audio power amplifier, such as mobile phones, MP4 players, laptops, television, audio equipment, and else. Furthermore, Class AB amplifier is an amplifier may be biased at a DC level above the zero base current level of Class B and above 1/2 the supply voltage level of Class A, which is the condition of this bias for Class AB. Class AB operation still requires a push-pull connection to achieve a full output cycle, but the DC bias level is usually closer to the zero base current level for better power efficiency as described shortly. For Class AB operation, the output signal swing occurs between 180 degree and 660 degree and is neither Class A nor Class B operation. In general terms, we see that Class AB falls between Class A and Class B in bias. It also falls between the efficiency ratings, which is between 25% or 50% and 78.5%.
So we use multi-sim software to stimulate the circuit to find the maximum signal power that required in the equation.
Okay, now let's start. So this is how we design our circuit. Okay, first, take the AC power, put it here. Next, basic, then resistor. Just take any value of the resistor. In this circuit, we have 3 resistors. You can change the value of the resistor later. Next, we have transistor, NPN, and PNP. Okay, next we have DC power. Okay, now we have VEE at the bottom and VCC at the top. Then take the multimeter for current and oscilloscope for output view. Rearrange all the elements in the circuit. here. So when we run the simulation, so here we get 470.544 milliampere. And then for the output, so here we get V peak 9.944. So let's do the when we run the simulation, we get the value of I equal to 470.544 milliampere. So here is IDC. Then from oscilloscope, we get the wave for class red color for output. So from this wave, we get 9.944 for V peak. So now we move to calculation. So here is IDC that we get from multimeter. Then here is V peak that we get from oscilloscope. Then we can calculate value of VRMS equal to V peak over Z2. So we get VRMS equals 7.031. Then we need to calculate P out. So here next calculate the value of P out. So P out equal to VRMS squared over Rm. Then we get 6.18 watt. So next, this is P in, and this is the formula of P. Let's calculate the value of P in. So here is the formula. Then we get 9. So here is the formula for P in. So we get 6.58 point.
The crossover distortion is the problem that occurs when both the transistors are off at the same instant. During the transition period, in order to eliminate this, the condition has to be chosen for more than one half cycle. Hence, the other transistor gets into conduction before the operating transistor switches to cut-off state. This is achieved only by using class AB configuration as shown in the circuit diagram we draw. Therefore, in class AB amplifier design, each of the push-pull transistor is conducting for slightly more than the half cycle of conduction in class B, but more or less than the full cycle of conduction of class A. The conduction angle of class AB amplifier is somewhere between 180 degree to 360 degree, depending upon the operating point selected. This is understood with the head of the graph in oscilloscope. More bias voltage given using bias voltage in V2 and V3 as shown in the circuit diagram, had the operating point to be above the cut-off point. Hence, the output waveform of class AB result as seen in oscilloscope. The crossover distortion created by class B is overcome by this class AB. As well, the inefficiencies of class A and B don't affect the circuit. So the class AB is a good compromise. Between class A and class B in terms of efficiency and linearity, having the efficiency reach about 50% to 60%. The class A, B and AB amplifier are called as linear amplifier because the output signal amplitude and phase are linearly related to the input signal amplitude and phase. In conclusion, class AB is a combination of class A and class B type of amplifier, as class A has a problem of low efficiency and class B has distortion problem. This class AB is emerged to eliminate these two problems by utilizing the advantage of both the class.